So, hello everyone. Today we have the topic called partial derivative. So, the first formula which we're going to talk about, this is a partial derivative of function fx,y. They have given like an x cube plus x squared, y cube minus 2y squared. And we are given to we should find delta f divided to delta x. It means we should take derivative respect to the x. So it is our task. And the next one, we should find delta f divided to delta y. It means we should take the derivative respect to the y. So how are we going to find this kind of relationship and from the functions? So first of all, let's get started from the finding delta f delta x. So we should take the derivatives respect to the x, and we should take the y as a constant. All right. So delta f divided to delta x, it's going to be our function is going to be so it's going to be that every kind of term we're going to spread that delta f delta x, right? It's going to delta f divided to delta x respect to the x cube plus delta f divided to delta x, and this is respect to this term is going to be x square y cube and minus 2y square as well, special this is going to be as well as delta f divided to delta x. All right, so let's get find the derivative respect to the x cube. So it's going to be this function is going to be equal to s3x squared plus this term is going to be equal to 2xy cube and plus this term. This is as a constant, this is a constant. It means derivative d divided to, for example, dx from the constant. There was a formula, if you remember, just equal to just a 0, right? So it's going to be that a constant derivative is always equal to 0. So this term, because there is only y, that's why we're going to consider this part as a constant. So it's going to be minus sorry, yes, this is going to be minus 0. So it's going to be equal to 3 x squared plus 2xy cube. This is a derivative respect to the x. So let's find the function df d delta y, delta f divided to delta y. So we should take derivative respect to the y, right? So it's going to be delta f divided to delta y. It's going to be equal to that every term we should spread especially as well as the delta f divided to delta y. So it's going to be delta f divided to delta y. So it's going to be x cubed plus delta f, it's going to be delta y, it's going to be x squared y cube, and it's going to be our delta f divided to delta y, it's going to be 2y squared. So it's going to be the answer is going to be, this is a kind of a constant because there's only x, there is nothing like a y, there is no y term. That's why derivative respect to the constant, it's equal always 0. So this part is 0. Then this part is going to be equal to, it's going to be 3y squared, because we have a y cube, derivative like a d over dy from the y cube, it's always equal to 3y cube, right? So x squared, it's constant. So this means we don't pay attention for this x squared, sorry. So that's why we should just ignore it. So it's going to be like a plus, sorry, this is going to be 0. 0 plus is 3y squared, it's 3y squared, and the minus, we should take the derivative respect to y. It's going to be just exponent goes down, it's going to be 4y and minus 1 from the exponent, right? It's going to be 4y. So the answer is going to be our as a 3y squared minus 4y, and this is respect to the delta f divided to delta y. So this part is going to be our answer for delta f divided to delta x. So it's going to be our partial derivative respect to the x and y. So if you have any questions regarding to our problem, it's problem number 1. So If you have any question, please you can just write everything in the comment section below, and I can going to answer for every your questions that you have, and just let me know. Thank you for attention.